Alright, I always hesitate to teach this, converting between radians and degrees. I hesitate to teach it, especially at the beginning of a trigonometry course, because if a student has a way to not work with radians and go back to the degrees that they love and know, they're going to do it. So I'm showing you this because it is absolutely necessary for you to understand this relationship. But I encourage you to work with radians, get to know them and love them as well, because you'll find that they can be more useful as you advance through your math classes. Okay, so just wanted to get that disclaimer out of the way. Don't abuse the power of the conversion. All right, so let's recall something that's crucial to the conversion here, and that is that 2 pi radians, that's the same thing as 1 revolution, is the same thing as 360 degrees, because that is also 1 revolution, right? Now, that's fine and dandy, but really what we're going to use a lot is, because each side of this equation is divisible by 2, it's also true that pi radians is equal to 180 degrees, which we knew, but we're going to focus more on that here, okay? So here we go. Let's do an example. Let's convert 60 degrees to radians. Okay, and we're taking a simple one. You may know the answer to this without doing any work, but I want to practice the concept here so you can do harder problems. Okay, so 60 degrees. 60 degrees is the same thing as 60 degrees over 1. I'm turning it into a fraction. You'll see why in a second. Now, I'm going to multiply this by another fraction. And I want the answer to be equivalent to what I started with. I want it to be equal to 60 degrees, which means that I've only got one choice for this guy, this fraction. This fraction has to equal 1. So that the answer that I get here is equivalent to what I started with. Now, 1 is really a versatile number. All numbers are pretty versatile, but 1 is especially useful. Okay, so what do we do here? What I want to do is I want to multiply by something that equals 1. That means the numerator and the denominator have to be equal to each other, right? For example, 5 over 5 equals 1 because 5 equals 5. So, whatever I choose on top and whatever I choose on bottom have to be equal to one another. So, the goal, though, is to cancel degrees. I want to cancel degrees. So what that tells me is I want to put, in my red fraction, I want degrees on the bottom to cancel the degrees on the top here. So I know that this fraction that I'm using is going to have a unit that is degrees on bottom. Now, what I want to do is get radians. I want to basically replace degrees with radians. So I want to replace with rads. So I'm going to put rads on top, okay? So you can see when you multiply these out, the degrees are going to cancel, all right? That's what we're working towards. The problem is right now, I don't have any numbers, so this fraction does not equal 1 yet. But if we use what we know about radians and degrees, then I know that I could put pi radians on top and 180 degrees on bottom. Those are equal to each other, so when I divide I get 1. So this is a fraction that equals 1. It's called a conversion factor. Okay? It's called a factor because you multiply by it. And so literally now when you multiply, the degrees cancel and you go straight across on top, so you get 60 pi, and you go straight across on bottom and you get 180. The unit now is rads, which you don't have to put on the top, you can put it out to the side. And if you reduce that now, the 60 and 180, you get pi over 3 rads. So 60 degrees is equal to pi over 3 rads. Okay? So now we can start moving a little faster since we have the concept. Convert 4 pi over 5 2 degrees. Notice I didn't label this angle with radians because in this context it has to be radians. It's an angle that we're converting to degrees. So the only choice here is that it's in radians. Okay, so we're going to start by saying 4 pi over 5. It's already a fraction, so I don't have to put it over 1. But I'll go ahead and throw in my radians unit, and I'll put it on top. That's the same thing as putting it out to the side. And I've got to multiply by my conversion factor that equals 1. In this case, I want to cancel radians, so I'll put radians on bottom, and I want to replace with degrees, so I'll put degrees on top. So that means I'm going to have 180 on top and pi on bottom, because 180 degrees equals pi rads. When I multiply, the rads cancel, and in this case the pi's cancel even. So I end up with 4 times 180, which is 720, divided by 5, and I've got that many degrees. So 720 divided by 5, I believe, is 144 degrees. So 4 pi over 5 radians is equal to 144 degrees. Okay, let's do one more. Convert, let's just do something like 2 rads 2 degrees. So this is kind of uncommon because there's no pi there, but it's still a number of rads. So we take 2 rads, turn it into a fraction, multiply by my conversion factor with rads on bottom and degrees on top, so I get 180 over pi. Now when I multiply, my rads cancel, my pi doesn't, so I end up with 360 over pi degrees. And that is the answer. If you want to understand that maybe a little better, you could approximate it by dividing 360 by pi, and it looks like you get about 114.6 degrees. Okay, so this is an approximation. 2 radians is about equal to 114.6 degrees. And that's how you convert. Set up your conversion factor so that the units cancel the way you want, and then just multiply straight across and simplify.